Okay. Okay. Hello students. Fine. So due to network issue, we have changed the. I think all of you have got the link, right? So fast, come fast. Already time is done. Time is running. Okay. So yes. So shall I start or even others they have to come? Because numbers it is showing different and messages are different. Okay, we will wait for 1 minute. Okay. Okay, I think all of you are here, right? Done. So I will explain it once again because I was telling something and when I turned, I was not seeing any messages from you people. So I got a doubt. So that's where video got ended. Fine. So I will repeat it once again. No need to worry. Okay. Okay. What is ground state? So ground state means, for example, we have an atom. So we have a atom. Okay. Now this is the electron which belongs to energy level 1. I am giving the answer for the question what is ground state. Okay na? So now this is where we have the next electrons, next energy level electron. Okay. So where I have the 8 electrons. Now I have 1 electron in the outermost shell. Imagining that I am talking about sodium. Imagining about I am talking about the sodium. Now when I will supply the energy, people have discussed, right? Photoelectric effect. So when I will supply the energy, I will supply energy in such a way that whatever electrons are present in this energy level, they can go to this energy level. Not exactly photoelectric effect where electrons will be released. We are not dealing with releasing of electron. I am telling whatever electrons are there at energy level 1, they can move to energy level 2. Or whatever electrons are there at energy level 2, they will be shifted to energy level 3. So what I mean to tell here is, now this condition where electron has moved from its original state to excited state, that is called as excited condition, right? So that's where ground state comes. Ground state means this is the one, original one, where without supplying of energy, where it is exactly present, electrons are located, that is considered as ground state, right? So when you are skipping, when you are jumping, you are above the ground, right? So that because you have applied the energy and you have jumped, but you will come back once again to your ground state. Same logic is applicable for electrons also. When you are supplying the energy, they will go to the excited state, but when you remove the energy supply, now they will come back to that original state. That original state is called as ground state. That means the amount of energy released when electron is added to atom in its ground state, in the sense where atoms are not excited condition, where atoms are not exposed to any energy. So that is the meaning of this particular statement, in its ground state. All of you have understood? So atoms are in the ground state means we are talking about the electrons present in those atoms which are in their normal form, not in the excited condition. Fine? So that's what ground state talks about. Fine? So now I was telling about release of energy. Values will be given with negative values. Utilization of energy, values will be given with positive value. I was telling. Right? Now, in that case, a very simple experiment. In your high school laboratory, or you can do once the college will reopen, you can take one beaker, in fact 2 beakers, In one case we have the sodium hydroxide, in another case we have the acid like H2SO4 or HCl. Now you can take another container where water is there. You can take another container where water is there. In one case we have sodium hydroxide, in another case we have the HCl, and in another case we have the water. Now if you add either HCl or NaOH to the water, now you can feel the container will become hot. The container will become hot. That means there is a liberation of energy which is taking place. That's why that the whole beaker has become hot. Now if I have sodium hydroxide pellets, it will be like a pellet. It will be in solid state. So when I take sodium hydroxide as a pellet, if you add it to the water in large amount, now there is a chance that the beaker is going to get cracked. The whole container will be cracked. So much heat will be liberated. So normally, if I want to have high amount of sodium hydroxide pellets in small amount of water, I cannot do that one in room temperature. So what I have to do is, I have to take the beaker of water, I have to put it in ice bath. I should put it in ice. Then I should add the sodium hydroxide pellets. Otherwise what will happen? High amount of energy will be released. Heat will be liberated. So that's where this condition is called as release of energy, which will be having negative values. Which will be having negative values. Fine? Now same way, if I take two organic solvent like hexane and benzene, or organic solvent when I am adding it to the water, right? So during that time the container or beaker will become cold. I have not added any ice, but still the container will become cold when you are adding organic solvent to the water, or when you are mixing two organic solvents with each other. That is because they are utilizing the energy. They are utilizing the energy from the atmosphere. Those values will be called as positive. Those values will be called as positive. Same logic, when you put the alcohol on the skin, what will happen? You will feel cold, right? That is because when alcohol will get converted into vapor state, it will get evaporated, right? During that time it will absorb the energy from your skin, from your body. So therefore you will feel like cold when alcohol drop is fallen on your skin surface. That is the reason. So during that time the value will be given as positive value. So exothermic, endothermic. So that's where we have the exothermic, where energy is released outside. Exothermic. Thermic means heat. Exo means outside. So energy will be released outside. So that's where I have the endothermic, where energy will be utilized. Endo means inside. Energy will be taken, heat will be taken inside. So therefore we have the positive value and negative value. Please remember these signs. Okay na? So negative sign and positive sign. All of you have understood definition of electron gain enthalpy, and what is that negative value and positive value. All of you have understood. Any doubts? If you have any doubts, let me know. Okay? So we can, if simply you can write, even no need to write ground state. Better if you write, but otherwise as if you are not getting that ground state word, you can simply write it as it is the amount of energy released when an electron is added to an atom. That is also fine. You will get the marks. Fine. So that's where we have the electron gain enthalpy. So naturally, based on the definition, can you tell me whether electron gain enthalpy should have negative value or positive value? Whether electron gain enthalpy should have the negative value or positive value? So based on the definition, and now just now I told what is that negative value and positive value. Can any one of you tell me electron gain enthalpy value will be negative value or positive value? Hmm? Which value? Negative value or positive value should be there? Because it is amount of energy released when electron is added to the atom. So therefore it should have the, okay, then you people have not understood what I have told. Now please remember electron gain enthalpy will be negative because there is a release of energy. There is a release of energy. That's what definition tells. Amount of energy released. Whenever energy is getting released, the value should be negative value. Right? Whenever energy will be utilized, then it will be positive value. Try to understand this one, okay? So always electron gain enthalpy will be having negative value. Always it will be having the negative value. Yes, it should have the negative value and it has the SI unit. Since we are talking about energy, it can be joule or calories. Anything is fine. So normally it will be given as kilojoules per mole or kilocalories per mole. Most of the time they will go with kilojoules, no doubt. Kilojoules per mole, SI unit for the enthalpy, electron gain enthalpy, because we are dealing with the energy. So therefore they have the SI unit or they have the unit. So kilojoules per mole. Now since we are adding electron which is negatively charged to the atom where there will be presence of positive, therefore there will be release of energy. Therefore there will be release of energy because, for example, I have a magnet and I have an iron nail. If I take iron nail to the magnet, automatically it will take the magnet, it will go to the magnet, iron nail. No requirement of our energy should be utilized. Automatically it will happen. But when I am taking this one iron nail away from the magnet, then I will be utilizing the energy. Same logic is applicable here. Same logic is applicable here. When I have the positive charge, when I am taking negative charge near to the positive charge, automatically it will happen. Right? So due to that, there will be release of energy. So energy absorbs, then it's positive, right sir? Yes, Achyuta. Now we have understood. Right. So whenever energy absorbs, it is positive. Whenever energy is released, then it will be negative. Fine? All of you have understood? So that's where we have the electron gain enthalpy value. Fine? So which will be having negative value and the unit will be kilojoules per mole. All of you have understood? Okay? Now, I will come to periodic table now. Electron gain enthalpy, all of us we have understood. Definition. Now we will come to the periodic table. Can you tell me how these elements are arranged based on the electron gain enthalpy? Which element will be having higher electron gain enthalpy in the periodic table? Can any one of you tell me in the periodic table how elements are arranged based on electron gain enthalpy? Naturally, if I gave Eg as the naming, electron gain enthalpy, now I can tell that don't use short form in the exam, please. Don't use the short form. To save the time, I am using the short form. Don't ever use short form. Okay now? So in the periodic table, electron gain enthalpy is going to increase as you move rightward direction. It's going to increase as you move rightward direction. What I mean to tell here is more amount of energy will be released whenever electron is added to the element when it is moving rightward direction. Right? So that means electron gain enthalpy is getting increased in the sense more energy will be released. More energy is released. Naturally, more negative value it will become. So don't go with the values. So electron gain enthalpy is getting increased in the sense more energy will be released. So now when you move down the group, electron gain enthalpy should be decreased. That means less energy will be released. Less energy will be released. All of you have understood? Less energy will be released. Right? So if I correlate with atomic radius, once again they are inversely related. Electron gain enthalpy and atomic radius, they are inversely related. Electron gain enthalpy and electronegativity, they are directly related. Electron gain enthalpy and electronegativity, they are directly related. All of you have understood? Fine. Now you might be having a question, sir. ಇದನ್ನೇ ಹೇಳೋದಿತ್ತು ಅಂದರೆ why the hell you confused us by telling that electronegativity is just attracting the electron? It's not gaining of electron. So many times you repeatedly told us, sir. You have confused us. Why you have confused us? That will be your question now. Right? Now the answer is very simple. Which is the element which is having highest electronegativity? Which is that element which is having highest electronegativity? Any one of you? According to Pauling scale, which is that element which is highly electronegative? Yes, that is fluorine. All of you will agree. After fluorine, which is that one? Which element comes next with respect to electronegativity? After fluorine, which comes next? According to Pauling scale, all of you are absolutely correct. Very good. Which is the next element? Saivam C. No bromine. Bromine will not come here. Okay? Highest electronegativity is fluorine. Very good. After fluorine, it is oxygen. Right? So if you see the values 4 and 3.5. All of you will agree? Not O2. No, not O2, only O. We are not talking about oxygen molecule. We are talking about oxygen atom. Okay? Don't get confused. So it is fluorine and oxygen. Right? In that case, electron gain enthalpy will be with high negative value for these elements. All of you will agree? In that case, these elements would have dominated even with respect to electron gain enthalpy. All of you will agree? Electronegativity is highest for these two elements. Right? Fluorine dominating, then comes the oxygen. But in that case, electron gain enthalpy also, they should have dominated. All of you will agree? Yes, Mansi? Okay, fine. Darshan, even. Yes, that should have been the reality. But that is not the reality. When it comes to electron gain enthalpy, observe it carefully. Chlorine is going to dominate. Chlorine is going to dominate, not these two. Chlorine is going to dominate when it comes to electron gain enthalpy. Please remember, electronegativity, yes. But when it comes to electron gain enthalpy, chlorine is the big boss. Chlorine is the very good acceptor of electron compared to fluorine. Can you imagine? That's why I told electronegativity and electron gain enthalpy, they are not one and all same. I'll come to that, Ashish. Very good. I was expecting that question. I'll come to that. So when it comes to electronegativity, that's why I told that they are not one and all same. Electron gain enthalpy and electronegativity, they are not one and all same. Definition itself is different. Right? So in one case it is attracting the electron, but here it is gaining of the electron. So in that way chlorine is going to dominate. Now, very good question. Why, sir, chlorine is going to dominate? I will explain it now. Now, if you observe it carefully, with respect to atomic radius, Achyuta, I will come to that. See, when I am talking about the periodic table, I have fluorine here, then comes the chlorine, bromine, iodine, right? So, fluorine, chlorine, bromine and iodine, right? So, neighbor, I am not talking about inert gas. One thing you should remember, inert gas or noble gases are the only elements which will have the positive electron gain enthalpy. Very important point. Electron gain enthalpy for all the element it is negative except inert gas, which will be having the positive electron gain enthalpy. That means they are very poor acceptors of electron. Which one? Noble gas. They are not going to accept the electron. Noble gas. They are very poor acceptors of electron. So that's 4. That's what indicates with they are having positive electron gain enthalpy value. What is the reason? That is because they have completely filled orbitals. They have attained the stability. So they don't want to disturb the stability. So they are not going to accept the electrons. That is because of the completely filled orbitals. That is because of the completely filled orbitals. So due to that, inert gas, they are not going to accept the electron easily. They will have the positive electron gain enthalpy value. Fine. Now I will come to next point, that is fluorine. Now neighbor is oxygen. It's a bit larger size. Now in oxygen we have the sulfur, which will be much more larger, right? Then comes the selenium, tellurium, everything will come. Fine. So that's where we have the arrangement. Here we have the oxygen. Now in their respective group, they will be having lower electron gain enthalpy value compared to the next element. They will be having lower electron gain enthalpy value. If I take fluorine belongs to period number 2. So therefore highest energy level will be 2. Another 2 minutes. Now I have 2 electron in the energy level 1. So how many electron in energy level 2? How many electrons should be there? It should be 7. There will be presence of 3, 4, 5, 6, 7. 7 electrons are there. I am talking about fluorine. Atomic number is 9. So 9 electrons should be there. So 7 outer shell, 2 inner shell. Fine. Now I will come to the chlorine. And all of us we know chlorine will be of larger size. So I have the 2 electron. Now comes 1, 2, 3, 4, 5, 6, 7. So that's where I have the chlorine. Now outer shell. I am talking about outer shell. Okay, na 7 electrons. So here also 7 electrons, and here another orbital should come. Okay, outer shell I am focusing. 7 electrons in the outer shell, 7 electrons in the outer shell. Fine. So in that case, can you show me or can you see here that space is less? In a lesser space, more electrons. In bit larger space, same amount of electrons. It's a simple logic. In a bench, we'll imagine 3 students can sit comfortably in a bench. Fine. Now I will ask another candidate to sit on the same bench. Now 4 students, they became 4. Right? So now students will be bit congested, but still they will be sitting in that bench. Now I will ask another one student to enter into same bench. I will ask another student to occupy the same bench. Now you can see the expression of students who are already present in that bench, who are already sitting on that bench. They will be like, ಈ ಸರಿಗೇನು ಆಗ್ಬಿಟ್ಟಿದೆ, ಇಲ್ಲಿ 4 ಜನ ಕೂತ್ಕೊಳ್ಳಿಕ್ಕೆ ಸ್ವಲ್ಪ ಇದು ಮಾಡ್ಕೊಂಡು ಕೂತ್ಕೊಂಡು ಮತ್ತೊಬ್ಬರು ಬರಬೇಕಂತ, right? So that's what students will get irritated, because in a bench where 3 students can sit comfortably, 4 students are there, that is fine, it can accommodate 4 students. Now I am asking 5th student to occupy the same bench. Naturally, students present already in that bench, sitting in that bench, will be get irritated, right? Same logic is applicable here. When I am asking another one electron to enter into the same energy level, now these electrons, to give space to those incoming electrons, they have to give some space. They have to rearrange themselves. But the same electron, when they are coming here, now these electrons will become upset. We don't only have this small space, and another new electron is also coming. So they will get irritated, not in reality. Now what will happen? Electron repulsion will start. So electron repulsion will happen, right? So negative charge, they have to repel, right? So electron repulsion will start, which will not happen here. So due to that reason, due to the small atomic size, fluorine and oxygen will have the low electron gain enthalpy value, due to the small atomic size. All of you have understood? Due to the small atomic size, they have the low electron gain enthalpy value. But electronegativity, yes, they have the electronegativity, because due to that small size only, where nucleus will be present here. So electron which is coming near to the oxygen or fluorine, they will be near to the nucleus. So positive and negative, they will attract, but they are not going to accept. They will attract, but they are not going to accept the electron in their shell. It will be outside only. So that is the difference between electronegativity and electron gain enthalpy. All of you have understood? Anyway, I will stop here, because you people will be having next class. I am really sorry, it's got delayed. But all of you have understood? So please remember, oxygen and fluorine, they have the lower electron gain enthalpy value. They have the lower electron gain enthalpy value. This is one point. Another point you should remember here is, when it comes to noble gas, they have the positive electron gain enthalpy value. They will have the positive electron gain enthalpy value. Even these points you should remember. Otherwise, almost all the elements, they have the negative electron gain enthalpy. And what is the unit? Kilojoules per mole. That will be the... Okay, sorry, there was a call. Okay, thank you. I will stop the class here. Take care. Okay, bye. Thank you.